Have you ever wondered how some of those massive parking lots at the mall or the airport just work? How they manage to keep things flowing so smoothly? Well, today we're going to peek behind the scenes. We're actually going to build a smart parking system, and we'll do it using some of the most essential tools a programmer has, data structures in C++. So let's dive right in.
We've all been there, right? You're running late, and you find yourself driving in circles in a packed parking lot, just hunting for that one open space. It's super frustrating, a total waste of time, and honestly, it's just pure chaos. That's exactly the problem we're going to solve today.
So, let's break it down. What's the real issue we're tackling here? It's those old-school manual parking systems. You know the ones I'm talking about, where it's just a person in a tiny booth with a roll of paper tickets. They're still out there, and they're the source of all the chaos.
It's like a domino effect, really. You waste time looking for a spot, which creates traffic jams inside the lot. Then the manual system can mess up, maybe give two people the same ticket number, causing even more confusion. And the result of all this? A parking lot that's not used efficiently and a whole bunch of really unhappy drivers. But what if we could bring some order to that chaos? What if we could build a parking system that's not just better, but actually smart? Well, that's exactly what we're about to do, and all it takes is the power of C++ and three really simple but incredibly powerful data structures. Okay, first up is the array. The easiest way to think about an array is like an ice cube tray. Every single slot has its own specific spot, its own address, and it can hold one thing. It's a super simple but really effective way to organize stuff, especially for something that's laid out like a grid, like a parking lot.
And this is where it gets cool. We can use what's called a two-dimensional array to create a perfect digital map of our parking garage. Let's say our garage has 3 floors, and each floor has 5 slots. Well, we can just create a 3x5 array to represent that. And just like that, every single parking spot now has its own unique address in our system.
Next on our list is the queue. And I promise, you already know how this works because if you've ever stood on a line, you've been in a queue. It's all about fairness, right? First one in line is the first one to be served. No cutting. It's that simple. First in, first out. So how does this help us with parking? Well, our queue becomes the virtual line for cars that are waiting to get in. When a new car shows up, it's added to the back of the queue. And as soon as a parking spot becomes free, the car at the very front of the queue gets the green light to go in. It's a totally fair and automated way to handle the traffic flow. And our third and final tool is the stack. Now this one's a little different. It kind of works in reverse. Think of a stack of plates. When you add a new plate, you put it on top. And when you take one, you always take the top one first. That's a stack. The last thing you put in is the first thing you take out. Last in, first out. So what's the stack's job in our system? Well, it's our official record keeper. Every single time a car leaves the parking garage, its information gets put on the top of the stack. This gives us a perfect history of all the cars that have left, and the most recent departure is always right there on top, easy to find. All right, so we've got our team, the array, the queue, and the stack. Now for the fun part. Let's see how they all work together to create a parking experience that's totally smooth and efficient. We're going to walk through it step by step just as if you were the driver. So first, you pull up the app and you see a clear map of the lot, all the free spots and all the taken ones. You just tap to book an empty slot and boom, your car is now in the virtual entry line. When it's time to go, the system automatically records your exit in its history. Oh, and if you forget where you parked, it happens, no worries. The system can find your car for you in a second. It's all seamless. And of course, you've got to handle payments. Our system takes care of that too. Because it knows the exact time you entered and the exact time you left, it calculates your parking fee perfectly. So no more trying to figure out confusing tickets or getting charged the wrong amount.
Okay, time to pop the hood and take a quick look at the code. Now, don't worry, you don't have to be a coding genius for this part. We're just going to see how these ideas we've been talking about actually look in C++. Would you believe me if I told you this one single line of code is the heart of our entire system? It's true. With just this little declaration, we've created the digital grid for our whole garage, 3 floors, 5 slots each. It just goes to show you how powerful a little bit of code can be.
And remember that virtual line we talked about? Well, here it is. This is the code for our queue. It basically has 2 main jobs, a function to enqueue, which adds a car to the line, and another to dequeue, which removes a car when it's their turn. This is the code that keeps everything fair.
And finally, here's the code for our digital record keeper. Inside this stack class, there's a function called push. Think of it as the function that stamps a car's exit information and puts it right on top of our history pile. This is how we keep track of everything.
So, you see, this isn't just some fun little classroom project. This is a real solution for a very real problem. And systems just like this are already changing the game for parking in cities all around the globe.
Just think of all the places a system like this can make a huge difference. You've got giant shopping malls, super busy airports, huge corporate campuses, the list goes on and on. And this is bigger than just convenience. It's a key part of building smarter, more efficient cities for all of us.
So what's the end result of all this? Well, you get a system that's incredibly efficient because it's fast and automated. It's organized so there's no more confusion, and it's super easy to use for both the drivers and the people managing the lot. It's truly a win-win.
And if there's one thing to take away from all this, it's this. Programming isn't just about lines of code. It's about being a problem solver. And when you have the right tools, like these fundamental data structures, you can start to tackle some really big, real-world challenges.
So I'll leave you with a question to think about. What's your parking lot problem? What's some everyday frustration that you think could be solved with a simple array, a queue, or a stack? The possibilities are literally endless, and I'm excited to see what you all come up with.